Welcome. In this video I'm going to show you how you can perform a one sample student's t-test for a mean. I have my data in column A, and the first thing I would be needing is the level I want to use at 95%. Note this cell is already set to percentages, otherwise type in 0.95 and then convert it to percentage, or just leave it at 0.95. We need a hypothesized mean, so let's say I think the average age in my sample would have been 50, so type in 50, and then let the calculations begin. The first thing is we need the number of samples or cases, which is actually column A, the sample size, 1969. We need the average, or the mean is in this case the average, which turns out to be 48. And basically we're testing if this 48 is therefore significantly different from this 50. The standard deviation is the sample standard deviation, which is the old standard def or standard def.s, which means it will actually be dividing by n minus 1 rather than by n, which in this case turns out to be 17.68. The standard error is the standard deviation divided by the square root of the sample size, which in this case turns out to be around 0.4, and the degrees of freedom is nothing else than the sample size minus 1. Then the test statistic is a t-value, which is the sample mean minus the hypothesized mean. That's this scary looking symbol up here. And then we divide that by the standard error, which we had up here. And then we can calculate the t-value, and we can either use the old t-dist function for that, and make sure you get the absolute value of the t-value, and then select the degrees of freedom, and usually you want a two-tailed, so 2, and that gives us a very low value. And the newer way of doing this is 2dist dot 2t, and it again requires to have the absolute value of the t-value, and we only need the degrees of freedom because the dot 2t already indicates that we want it two-tailed, and it should give us the same result. I already had these put to number format, so if it's generic it will give you the scientific notation, and back to number, and usually you want it at 3 decimals. This is below 0.05, so remember, if the p is low the null must go. So the null hypothesis was that it was 50, and this indicates that it's significantly different from that. And that's all there is to it.